Welcome to ELM Prep Part 3. And we're going to talk a little bit about the XY plot, or as it's called, the Cartesian plot. The XY plot is essentially just a number line, except that it is a number line in two directions. We have a number line left and right like we had before, and we call that plus x, and we call it minus x, where we called this just plus and minus originally. 0 is in the center. We also have a plus y portion and a minus y portion. So going down below the x-axis would be negative y. Going above the x-axis would be positive y. So we count up 1, 2, 3, 4, 5 on up to infinity. Minus 1, minus 2, minus 3, down to minus infinity in the y direction. Well, this is helpful because the number line was very limited. We could go plus and minus. We could find out the distance between them. But a lot of our world is something other than just distance or measurement. A lot of it has to do with area or diagonal directions, or you might say this is north, south, east, and west, and we could map with this kind of a coordinate system. And in fact, we essentially do have a mapping system that is based on the Cartesian. So all this is saying is that we now have two parts to our any point on this map. It could be on the line, any line, or it could be in between, any point in between the x and y axis. But every point has an x component and a y component. How far in the x direction and how far in the y direction did I go to get to that point? So any point on the Cartesian will have these two coordinates, and we call them coordinates because they're pairs of coordinates. And so I could have a point here that would maybe be 3, 4. That means I went 3 in the x direction and then 4 in the y direction to arrive at my final destination, starting at 0, 0. The center is 0, 0, 0x, 0y. All right, well, what are the kinds of questions we might ask you about the Cartesian plot? Well, we might give you point A and point B and say, well, what's the relationship between these? Well, if I were to just go equal distance x and y, over 1, up 1, over 2, up 2, I would plot a sequence of lines that would be diagonal like that. So every point on this line has an equal x and y. So x and y are equal, 3.5, 3.5. If it were in between a whole number, then it would be some fractional part, but they would be equal. The x and y would be equal any point on that diagonal line with a slope of 1 that went through 0, 0. All right, so what about this point? Well, if I took some point, let's say I had a point here that was 3, 3. And let's say I went above that line. We went upwards, but we didn't move left or right. We just went upward. That would increase my y. So maybe I might be up here at 3, 5 at a point up here, or 3, 6, or so on. The x remaining constant and the y changing. Well, that would say that every point above this line would have a bigger y than it did an x. So any point in this region, my x would be less than my y. So the y value would be larger than the x value. Well, conversely, if I took some point here that was 5, 5, and I went downwards in the y direction, the y would decrease, so to maybe 5, 4, 5, 3, etc. And so every point down here would have a smaller y value, and the x value would be greater than the y value. So, just as a general rule of thumb, if I were to draw a line at the 45 diagonal with a slope of 1, all of the points up here would be x less than y. Well, all the points here would have x greater than y. So all of these points down here would be x greater than y. So if I were to pick any point A up here and B up here, one thing I might say is, well, find a point where x is less than y. Well, that would be this point up here, because all of the points are in this area. The y is greater than the x. All of these points would be x greater than y. So we kind of did a quick trip from a simple number line to what we call the XY plot, or the Cartesian plot. It is a two-dimensional plot and therefore gives us values in two directions, up and down and left and right. So if I were to draw some point here and say that that point were 2, 2, and some other point over here that maybe is 5, 3, I could find the slope between these two lines. If I drew a straight line between those 2 points, that line would have a certain slope to it. That means that I go some distance up, what we often call rise, and I go some distance to the right that we call run, or if you want to think of run as being to the right, that's perfectly valid, and rise being the up or down, as the case may be, because I may be going down from one point. So in looking at these 2 points, I have some change in my x direction. I changed from 2 in the x direction to a 5 in the x direction. So I went this distance in the x. So that I went from 2 to 5. And we learned in our number line, well, the distance between those would be this one, the upper one minus the lower one. So I went a distance of 3 in the x direction. We always go plus in the x direction, and then we go up or down as needed. Well, I went from 2 in the y direction to 3 in the y direction. So I went from this point to this point. I went up some small amount in y. I went from 2 to 3, and so I went up by 1 in the y direction. So if I take the rise over the run of 1 over 3, my slope, which we indicate with the letter m, the slope of that line would be 1/3. Now certainly I could have a line up here that would be parallel to it that would have the same slope. And in fact, if I have parallel lines, these slopes are equal. And I could have any number of parallel lines, and the slope of each line would be the same. The equations would be somewhat different because they pass through the y-intercept at different points. But the slopes would be the same. So parallel lines have the same slope. Okay, so let's refresh on the Cartesian plot. Plus x minus x, so we go left and right in the x direction. We go y in the positive and y in the negative are up and down. So if we have some point out here, we're going to go some x distance and some y distance, and we're going to designate that point in terms of that x and y that I traveled, x, y, and we call that a coordinate, a Cartesian coordinate plot or point. So the x value and the y value tell me how far I went to arrive at that point from the 0, 0. I could go negative some value and positive, and so this would be some minus x and some positive y, and so this point over here would be a minus value and plus value. All right, that's very basic XY plot, and we will find that we will use that as we go along here. Hope you enjoyed this. Hope it was somewhat informative. Have a good day.